Okay, this is a video over the derivative notation for the chain rule. And what I want to do is I'm going to write the equation, say y is equal to the quantity, and I'm going to say 3x cubed plus 2, and that whole quantity to the 6th power, okay? And what we've been doing is we've been saying, okay, if I'm going to let my inside function be this function u, so if I wrote over here u is equal to 3x squared plus 2, okay, then I'm going to rewrite my function over here as y equals u to the 6th, okay? Now, what I want to do is take the derivative of this function here with respect to x, okay? And that's what I'm doing up here as well, okay? I'm taking the derivative with respect to x. Okay, now, since I'm taking the derivative with respect to x, I have an x here, but this is not an x. This is a u, okay? These are not the same. So what I would do is, if I'm calculating the derivative, I'm going to get dy dx is equal to 6, let me erase that, 6u to the 5th times u prime, okay? And we calculate u prime up here, and we can just say, all right, well, this is just going to be 6x. Now, the other thing that I can say, instead of writing u prime, based on the last video, we can write this as du dx. Because essentially that's what I did, okay? I took my derivative up here with respect to x. This is what I'm doing. This is the underlying thing. I'm finding the derivative. X is my variable, okay? Now, when I do that up here, I can write either u prime, which is 6x, or I can write du dx, which is also 6x. Now, down here, we've been writing it this way, okay? We've been using the notation u prime, and I'm going to continue to do that. But what I want you to see is that I can rewrite this as dy dx is equal to 6u to the 5th times du dx, okay? Both of these are the exact same thing, okay? If I write dy dx, I can write it, using the chain rule, you can think of it like this way. This is totally fine to think of it like this way. But you need to also see it in this form and understand that these are the same thing, okay? This is u prime, this is du dx, they mean the same thing. We're going to get 6x, okay? So if I wanted to write the entire derivative of this entire function here, I would say dy dx is equal to the 6 times the quantity, 3x squared plus 2, all raised to the 5th power, but then we have to multiply by u prime, which is 6x. Or we could multiply it by du dx, which is the same thing, 6x. So I'm going to multiply that by 6x, okay? So what I hope is that you can see the relationship between this and this, okay? Where I'm using this in the chain rule, okay? Now what I want to do is I want to think about, I don't want to do that. I want to think about something else, okay? I'm going to think of the equation for a circle, okay, of radius 1. And I'm just going to write the equation x squared plus y squared is equal to 1, okay? And you'll see this example again in your notes. But what I want to do is I want to find dy dx, okay? And so if I wanted to find dy dx, now notice that this is an equation, okay? This is not a function, all right? This is an equation for a circle. So what I would want to do is take my derivative with respect to x of this equation, okay? So here's what I get, okay? I'm going to take ddx of x squared, okay? And then I'm going to take the derivative with respect to x of this, which is y squared, okay? And then I'm going to take the derivative with respect to x of 1, okay? And so what I want you guys to see here is that I can take the derivatives of each of these terms, okay? Now, I want you to notice here that my derivative, if I take the derivative with respect to x of a term that has the variable x in it, I'm just going to take its normal derivative, okay? And I'm going to get, what is that, 2x? Okay, this is going to give me 2x. Okay, if I take my derivative with respect to x of this, which is y squared. Now, guys, the x and the y do not match. So here's the rule of thumb. Okay, we have to use the chain rule here. That's the basic idea. But I'm going to take my normal derivative. So I'm going to get plus 2y. But then I have to multiply by y prime. I have to use the chain rule here. These do not match. Y I'm considering to be a function. Okay? So, and then I can take the derivative over here with x and 1. If the derivative of numbers is going to be 0. Okay? So, but I don't want to use y prime. Okay, that's what we've been doing when we use the chain rule. But what I want to do is I want to write this as 2x plus 2y times dy dx, and that is equal to 0. Okay, and this means the same thing, but we're going to need to be able to put it in this form, okay? And the reasons why we have to write it in this form will come later in the year when we start doing something called integration. But what I want to do is, let's finish this out, and let's actually solve for dy dx here. And so what I want to do is that this is a noun. Okay, I want to clarify that this is a noun. I'm going to solve for this for dy dx. Okay, so I'm just going to solve this like I would any equation. I'm going to subtract 2x from both sides, and I'm going to get 2y is not 2y is equal to 2y times hold on. I'm going to do 2y times dy dx is equal to negative 2x, okay? And so now, let me move this down a little bit. I'm going to divide everything by 2y and 2y, okay? So I'm going to divide these by 2 and y, those divide out. We are simply left now with dy dx is equal to negative 2x over 2y. Now the 2's divide out, so now we can write this as dy dx is equal to negative x over y, okay? And so that's my derivative with respect to x, okay? But the difference is that this also contains the variable y, okay? So these are, we're taking the derivatives of things that aren't functions, okay? And they contain multiple parts, multiple functions within those. So I'm going to go over this and kind of show you a picture of this and do this problem again in your notes for 3.8, which is implicit. We call this implicit differentiation. Implicit, if I could write. Implicit differentiation. Okay, so we'll talk all about this, but I wanted to make a video kind of explaining some of this notation. Hope this helps. Thanks. Bye.